Hey, what's up, guys? Moving on, chapter 2 today. Okay, we're starting to kind of dive into some actual statistics here. So this whole chapter is on displaying and describing categorical data. So remember what categorical data is, where we have counts, we have categories. We put the counts in the categories. So, first thing to remember as we move throughout the year here, very, very important to make a picture. Okay, and we're going to talk about how to make pictures, what to make them of, what types of graphs and such for what types of data and all that. So obviously you see a lot of things in a picture that you wouldn't see if you just strictly showed the actual data or the numbers. So that's what hopefully we can show you here today. Okay, so first off, frequency tables. Kind of mentioned this in the last chapter. We can, they call it piling the data into categories. And you can see here's our different categories of our variable. Okay, this is numbers from the Titanic. So this is first class, second class, third class, and crew. And so as you can see there, it's the frequency in each category. So hence frequency table. Okay, next thing along with that, there's relative frequency tables. Okay, basically the same thing. It's just it shows percentages. So when you see relative frequency table or relative whatever, it's just talking about percentages. That's all that means. Okay, so you can see those are the percentages of the people on that boat. Okay, so both tables to show how the cases are distributed across categories. Okay, that's a key term there. They talk about, or when I talk about describing a distribution, okay, you're going to hear that a lot. So if I'm describing a distribution of a categorical variable, a frequency table and relative frequency table is kind of the start of that. Okay, and remember, relative frequency is just percent. All right, so there's lots of bad graphs out there, and we'll kind of show some as we go. But here's one showing the same data, but not in a very effective way. So if we look at this, the crew, third class, second class, first class, looks like the whole ship was made up of the crew and just a few other people there. So, which is not the case. Obviously, the crew did have the most, but it makes it look like this is like 5 times the amount of that. Okay, so and things like that, it looks cool, whatnot, but not effective if you're trying to display data. What it violates is called the area principle. Basically, the area occupied by a part of the graph should correspond to the size of the value it represents. Okay, so long story short, make it simple. Something like this doesn't look quite as cool, but get rid of that. Doesn't look quite as cool, but it shows your data in an effective way. It's the more professional way to do it. So this is a bar chart. You guys have seen bar charts before. This is one way to display the distribution of a categorical variable. You can see you've got your different categories, your frequency. So it's just a frequency table in graph form. Okay, a relative frequency bar chart, just like a relative frequency chart, it shows the percentage. Okay, so the relative proportion. So relative to the whole group, That's what all these are. Okay, if you look, the shape is exactly the same. Only difference, vertical axis, our percentage of the total. Okay. All right, pie charts, the other way to display categorical data. You've also seen these. I'm not going to go into a ton of detail how to make them. You just want to make sure they add up to the whole. Not much to it there. That's a regular pie chart. You could make relative frequency and put those percentages in there as well if you wanted to. Generally, we don't make pie charts by hand. They're not easy to do to try to split up a circle by the correct percentages. So you would use a computer program for that. Okay, so let me go back here. Actually, we'll keep going. So the next thing, contingency table. Lets us compare 2 variables together. So this is the class, so like the first, second, third, and crew, and the survival, so people that lived and did not live. So you can see breaks it down a little bit, lets us look at in a little more detail and be a little more specific, which we'll get into that in a little bit here. A key term you need to make sure you know when you hear marginal distribution. So if I say describe the marginal distribution of death, so that's basically our totals. So it's how are the totals distributed for survival. So you would say 711 out of 2,201 lived, 1,490 out of 2,201 did not live. That would be describing the marginal distribution of survival. Okay. You could do the same thing with class. All right. If I said describe the marginal distribution of class, that's just these totals. Okay. So you'd say, and you could do this as percentages also, or you could say the first class was 3 to 25 out of 2,201 and so on. That'd be marginal distribution. That's just the totals, which easy way to remember that. Marginal distribution is what occurs in the margins. Okay. Okay, each cell of the table gives our count. Obviously, you can see there, this spot right here would be crew members who died. Okay, we can use that for a variety of things, such as when we start talking about conditional distributions. Okay, so this right down here is a conditional distribution of ticket class conditional on having survived. So basically, it's out of the people that lived, what percentage were crew? So out of all the living, so all the people that made it to shore, 29.8% of them were crew members. Okay. You can do that with, whatever out of this. You can do it out of the ones that died, or you could look at out of first class, what percent lived, or whatever. Okay. It's conditional distributions. Conditional on something happening. Okay, the same thing, just this conditional distribution on having perished or not lived. Okay, you can also compare pie charts of the same thing. Okay, so alive, dead, you can see, okay, well, it looks like crew. Much more of the people that died were crew in third class. Okay, something that you don't really see if we just look strictly at this. It's kind of hard to tell that. If you look closely, you can see it, but really, you can see it here, these percentages, or here. Okay, with the pie charts. The other one you can use, which we'll get to the next slide, is a segmented bar graph that also shows similar information. But here, we'll talk about, if you look at that, if you go back, you can see third class and crew, way more of the people who died were in the third class and the crew. First class and second class, we're a little bit better off. So you can think, okay, so then why might that be? All right, that's something we can see with the pie charts. All right. So what that tells us, since it looks like the third class and the crew seem to be more likely to not live, all right, what that tells us is that there might be some sort of association between class and survival. Okay, that's going to be a key word throughout the year here, is association. All right. If we say there's an association, we say they're not independent. All right. You might think, why don't we call it dependent? Well, we don't necessarily call it dependent because it doesn't necessarily mean that the class depended on the survival or vice versa. We just need to know that there is some sort of an association. Okay, it's kind of, you'll hear me talk about using kind of politician words where we don't want to necessarily make a firm stance that this is dependent on that. We want to say there might be an association. Okay, using words like that. If it didn't look like there were any differences in those pie charts, so it didn't matter what class they were and no matter who died, then we'd say they're independent. Okay. So this is a segmented bar graph or segmented bar chart. It's basically the same information again, just a different visual. Okay. So sometimes you can see more with these than you would with a pie chart. It just kind of depends. But one thing to note, if we say they're independent, that means basically all these parts here. So like these two here would be basically the same. These purple ones would be the same. The sort of like whatever different shade of purple would be the same. And these greens would be the same. That would mean they're independent. Okay. When you see all these differences, that means there's some sort of an association. All right. I want to show another example of some reasons why it's important to make graphs. Okay. You guys may or may not have seen this. Obviously, hot topic right now. The Republic always reports there's blank new cases, blank deaths. It doesn't necessarily, unless you follow it every day and you chart it, you don't really know or remember what's happening. Is that more or less? Well, it just sounds like a lot. I don't know. Is it? But so that's why it helps to have pictures. Okay. So we can see here positive cases. Okay, went up and went back down at the start of summer, and then we're going back up again. You can see when it is that I made this video here. But you can really see the trend is going up again, all right, which you wouldn't necessarily know if all you saw was this. Or back in the summer when you were just going to report a blank new cases, the picture shows a lot more. Okay, I can see cumulative cases. That's another topic for a different day. You can see right down here. Okay, what do we have here? Well, it's a bar chart with percentages, so we call that a relative frequency bar chart. This is on age, okay? Age of positive cases. You can look at age of deaths, same thing, okay? Relative frequency bar charts. All right, so see them everywhere. It's important, obviously, important to know how to read them. Most of you probably already do, but the skill to be able to create these and to know what to create when, okay? All right, so back to it. All right, so that's really most of the information. So there's a couple things to take note of. Things that can go wrong. Don't violate the area principle. Okay, the pie chart over here on the left, it looks cooler, but it's 3D, but it doesn't. It's hard to tell if these are really different, but you can see it. They are here. Okay, it almost looks like the third is more in this case. So things to take note of. Just keep it simple. Okay. Couple graphs here. These are actually put out by different news organizations, as you can see. The one on the left says Americans who have tried marijuana. So 51% today, 43% last year, 34% in 1997. All right, well, we can see it went up, but why do they have a pie chart there? The pie chart is meaningless. Okay, these don't add up to 100. They're not all in the same group. Okay, so it doesn't make any sense to put a pie chart there for this one. Okay, this one over here, this was back in 2012. In the GOP primary, you can see the percentages there in a pie chart don't add to 100%. All right, where those numbers came from, I do not know. All right, it doesn't make a whole lot of sense. So there you go. We'll look at some more bad graphs later on because there's been a lot of them. And you'll see them in the media often. Right? It's why statistics classes are very, very important, and that's why you should take statistics class and encourage your friends to do that. Okay, so you don't make the same mistakes that these people made. Anyway, sort of things just to take note of. This is really important right here, and this is probably the hardest part of this chapter. Similar sounding percentages, you have to really, really pay close attention to the wording. So if I ask you what percentage of males are seniors and what percentage of seniors are males, that's definitely different. Okay. This first one, what percentage of seniors are males? So that's out of the 350 seniors, how many are males? That would be the percentage there. This one, what percentage of males are seniors? So that's out of the males. So that's probably, 700 some people. What percentage of those 700 are seniors? So you can see they're two different things, but just flipping the words, very, very important. Okay, so just take note of that. That's going to cause you probably the most amount of trouble on the homework, I think. Okay, make sure you don't claim something you can't just because you have it on a graph. Just like, I went back to the coronavirus. It looks like it's going up, but is it really? Maybe it's just a couple of days. I might just say, it's blowing up out of proportion. I guess we'll find out. We'll know what happens here in a few weeks, probably. But anyway, another thing called Simpson's paradox. It's kind of an interesting paradox, but it's where you average one variable across different levels of a second variable. I've got an example with baseball that we'll look at that kind of shows this. It's not an actual AP topic, but it's something that's pretty interesting to think about. So we'll talk about that later on. So there's just obviously summary of some things. You can read through this yourself. You can pause the video and take a look at it. I'm not just going to read it to you. You know, you guys are capable of reading. And then just one thing, make sure always label and scale your graphs. Don't leave them blank. Okay. You know, or something like this doesn't, you don't get credit for it, but it doesn't show anything. Okay. You get it in the real world. You're presenting something to a group and you just show them that. Okay. Obviously not going to have a graph of your relationship, but regardless. All right. So take a look at, read this. All right. Little zinger here at the end. So, that's it. Hopefully all this made sense. Let me know what questions you have. Okay. Oh, sorry. One more thing. Checking for independence. We talked about that briefly, about if there's an association or independence. We'll talk a little in this chapter, but we really come back to it more later in the year. Okay. But it's important to kind of understand the difference if I say there's an association or if they're independent, knowing how those differ by looking at a graph. So now that's it. So let me know if you have any questions. Have a nice day.